Alright, so now that we have refreshed ourselves with polar graphs, let's jump back into converting between rectangular and polar coordinates and equations. So in order to make our conversions, we have to remember these relationships here and here. So converting from polar to rectangular, we simply take the r value and multiply it by cosine theta for x and sine theta for y. Converting from rectangular to polar is a little bit more involved. We use the Pythagorean theorem relationship that you've already come across in trig before, that r squared equals x squared plus y squared. And then we use tangent theta as y over x to figure out that angle for the coordinate point. So let's jump into an example. Example 6, convert the following coordinates as specified. So for the first one, you can tell we are in polar form because you can see an angle as one of your coordinates, and then that means that this is your r. So we're basically taking this coordinate point and we're converting it to a rectangular coordinate point that we're used to working with. So I kind of just keep it as a coordinate point, but set up my r cosine theta and r sine theta. So in this case, that would look like 2 cosine 5 pi over 6, comma, 2 sine 5 pi over 6. And then you can, of course, simplify this. Often on the free response question or something like that on the Apex, you would not have to actually simplify, but just for practice. So cosine and sine of 5 pi over 6, if we remember, 5 pi over 6 is a little under a pi, and it's the over 6 guy, so he's over here, which means it's a negative long and a short up, right? So that means that this would be 2 times negative root 3 over 2. That's a multiply, comma, 2 times. The y value would be the short length, which is a half. And then you would just simplify from there. So our rectangular coordinate point is negative root 3, comma 1. Now on part B, we're going the other direction. We're starting with the x and y, and we're converting to the radius and the theta. So we're using these relationships here. Usually I find the r first. So for us, that would be 3 squared plus negative 3 squared. So it's going to be the square root of 9 plus 9, which is simply 18, which you can rewrite if you would like to pull out a 9 and write it as 3 root 2, but typically I just leave it as root 18. And then to find the actual angle, we also have to find tangent of theta, and we use tangent because it involves y and x, which is what we're starting with. So in this case, that would be a negative 3 over 3. So basically, where is tangent theta equal to negative 1? And there's lots of ways to write that position as we've reviewed with polar coordinates. But we're thinking about quadrant 4 here, 3, negative 3. He's down here, right? So you can think of that as negative pi over 4 or 7 pi over 4. That's really either way, honestly. Inverse tangent would be negative pi over 4, but if you would like, you can also express it as 7 pi over 4. As long as you understand the relationship of polar coordinates and that we can write them in multiple forms, I think we're good. All right, and this concludes example 6.